As a result of the enormous growth of civil air traffic, the positioning of arriving aircraft at large, sophisticated airports like Heathrow or Chicago is a very complex operation. This is extremely demanding on controllers, and the use of radar in helping them to construct a picture of all the arriving aircraft has become vital. Radar is used in approach control to perform the following functions: radar vectoring for arriving air traffic on pilot-interpreted final approach aids, or to a point where a visual approach can be completed, radar monitoring of parallel ILS approaches, radar vectoring of arriving air traffic to a point where a precision approach radar or a surveillance radar approach can be made, radar monitoring of pilot-interpreted approaches, in compliance with the procedures, conducting SRA and PAR approaches, providing radar separation between succeeding departing aircraft, succeeding arriving aircraft, departing aircraft, and succeeding arriving aircraft. Because of the very large numbers of aircraft arriving at big airports, and the very complex task of lining them all up for safe and efficient approaches to land, procedures must be in place to ensure that aerodrome controllers are kept informed of the sequence of arriving aircraft, and that safe separation between them all exists. Before radar vectors onto an approach are passed to the pilot, he will be advised of the type of approach he is elected to use and the runway in use. He will be given his position at least once during this time. An instrument approach under radar direction can be broken into phases. The initial and intermediate phases comprise the approach from the time radar vectoring starts until the aircraft is on final approach, and is established on the final approach path using a pilot-interpreted approach aid, reports that he is able to complete a visual approach, is ready to complete an SRA, is transferred to a PAR controller. Aircraft that are vectored onto a final approach will be given a heading or a series of headings to fly by the controller that are designed to close the aircraft onto the final approach track. The final heading is designed to establish the aircraft in level flight on the approach prior to it intercepting the specified glide path. This angle should provide an intercept angle with the final approach track of 45 degrees or less. Should a controller vector an aircraft through the center line of the final approach track, then the pilot will be informed why this is necessary. If the aircraft is being vectored to intercept the localizer, MLS final track, or other pilot-interpreted approach aid, the pilot must report when established on that final track. Radar vectoring will normally terminate when the aircraft leaves the last vectored heading to intercept the final track. Vectoring for visual approaches may be initiated, provided that the reported ceiling is above the minimum altitude applicable to radar vectoring, and meteorological conditions are such that with reasonable assurance, a visual approach and landing can be carried out. A clearance for a visual approach is only to be issued after a pilot has reported the aerodrome or the preceding aircraft in sight, at which time radar vectoring will be terminated. Once the radar approach controller has completed the procedure of placing the aircraft on final approach, control of the aircraft will be passed to the aerodrome controller as soon as the aircraft has been issued with clearance to land and sufficient time permits compliance and acknowledgement to take place.